Today we're going to take that idea with the normal curves and we're going to be kind of looking at stuff from a little bit of a different perspective. Really what we're going to be doing is kind of hearkening back to percentiles. If you remember way back when we did those in Unit 1, when we did percentiles. So we're kind of doing percentiles. So if you think about when we learned percentiles, we were given some information and we were asked to find what the cutoff of height is or test scores is for the highest 10% of people or the lowest 10% of people. That's what we're going to be doing now, except we're not going to be given any information except for the mean and the standard deviation. But it turns out percentile is just area. When we're talking about the highest 10%, that's the 10% of the area is shaded on the top, 90th percentile. When we're talking about the lowest 10%, that's the 10% of the area shaded on the bottom. So we've been doing that for a couple of lessons now, right? Because the area is the probability. And so we have the area under the curve, and we've been finding the probability of landing in that region. And we've been doing that since lesson 14. And in a lot of ways in lesson 13, we were doing that as well too. We've been told what values we're looking for, what X values, and what the probability of an X value landing in a certain region is. But now we're going to be told the area, and we're going to find the X value. So we're kind of doing the opposite direction that we've been doing before. Here's an X value, tell me the probability, and that probability is area. And in this lesson, it's going to be, here's the area / probability, tell me what X value corresponds to that. And then at the end of the lesson, we're going to mix it all up. And your job is going to be to determine whether or not we're looking for the X value or we're looking for the probability. So we have the normal distribution, and this is, like I said, part 2 of the normal distribution. Notice here, this is from example 1 on lesson 15. And I copied it here because this is the crux of the empirical rule. We have the 68, 95, 99.7 rule. And if you've got a normal curve, we've got the z-scores down here and the standard area here. And I've written them in both percentages and decimals. All right, and then I also have some questions here to just kind of practice the normal curve, the z-scores and the meaning of the z-scores. But what I'm going to do before we move on is make sure that everyone's on the same page with the area of the curve. We're going to do 7, 8, 9, and 10. So 7, you see I have worked out here already. What's the probability a randomly chosen 5-year-old boy weighs between 40 and 45 pounds? I should have mentioned at the beginning, we have a boy's weight is normally distributed with a mean of 43 and a standard deviation of 5 pounds. So I made the curve here, and remember that is starting out with the mean in the middle, and then going to the right, adding 1 standard deviation for each tick mark. And then remember the z-score down here tells us how far away that value is from the mean, where these on the right are all positive z-scores, and these on the left are all negative z-scores, where positive means you're above average, above the value being above the mean, and negative z-score means the value is below average, or what we refer to as below the mean. For this one, we can do it one of 2 ways. If the value we're trying to find, these values here, the probability of between 40 and 45, if they land on one of these values here, I can just use the empirical rule and use these probabilities. Okay, I can also use my calculator. Remember, the calculator gives us an exact answer. The empirical rule are approximations. So this area here isn't exactly 34%. It's more like 34.1%, but the empirical rule gives it close enough that we use that as a good approximation without having to use the calculator. But any values we're trying to find that aren't landing on these exact integer standard deviations, our only option is to use the calculator. Because remember, this curve is symmetric, but these regions here are not symmetric, so we can't just cut them in half. So if we were trying to find the value halfway between here, these 2 areas are different. And hopefully you can just see that from the shape. For number 7, what's the probability a randomly chosen 5-year-old boy weighs between 40 and 45 pounds? You see how I've drawn this little diagram here? The mean is in the middle, and the mean, remember, is 43. And I really suggest that you do this for 2 reasons. First of all, it helps you see what's happening. It helps you gauge whether or not the answer you get seems reasonable. Also, it helps you see what values to put in your calculator. A lot of times that visual is helpful for figuring out what numbers to put in your calculator. For this first one, I'm doing between 40 and 45 pounds. So you see I have 40 here and 45 here. So I've shaded that area. So I'm going to use normal CDF. Remember, normal means I'm using the normal curve. C for the cumulative probability, and DF for, I don't know what the DF stands for. I read it somewhere. You can look it up if you're interested. So and the order in your calculator is always the same. The min, or the leftmost value, which is 40. And notice that 40 shows up two other places. The 40 is here, it's here, and it's here. And then we know it goes there. 45 pounds, so that in my inequality is there. It's also here, and it's also here, okay? And then always mean and standard deviation. All right, and you put that in your calculator, and you should get a 0.381. I wrote this check here to say, yeah, that seems reasonable. Because if we go back up here to our normal curve, we're doing 40 to 45, which is somewhere roughly here, okay? And I know combined that bigger area is 68. And it looks like I'm kind of cutting each of these in half, doesn't it? Half of that, a little more than half of that. All of this combined is 68. So taking this bit here, 40 seems about reasonable. Okay, anytime you get a value out of your calculator, be it an X value, or a Z value, or a probability, you should always stop and ask yourself, does that value make sense? Does it track with what I know about this? And especially, I'll just say here, when finding the Z scores, if I put this in my calculator without the parentheses around the top numbers here, I would get a vastly different number, 31. If I have a weight of 40 pounds, looking at my graph here, I can see I should get Z-score of around a half, -1/2 or so. So if I get a value out of my calculator that says 31, I should know there's something terribly wrong happening. We shouldn't be seeing something that huge. That's not to say it's not possible. It is possible. It's just extremely unlikely. So question 8, take a moment and think about, I've got the drawing here for you for question 8 and what that's going to look like. I've written the probability for you. We're finding the probability randomly chosen 5-year-old boy weighs less than 36 pounds. Think about what you would put in your calculator here. And then the same one for more than 50 pounds. For number 8, we're looking at values that are less than 36. So for the minimum, we want to think about, again, what's the minimum possible weight someone could have? When you're doing the less than, the minimum value is 0. And then the maximum value is here. That's that 36. And then the mean is going to be the same that we did above. Okay, and before we put it in our calculator, I'm just going to do the next one, and we can put them both in our calculator at the same time. Okay, so what's the probability that a randomly chosen boy weighs more than 50 pounds? So that's here. The leftmost number now is 50. The smallest possible number is 50 pounds. And then the biggest possible number, well, we don't know how heavy average 5-year-old boy could be, or we don't know how heavy the heaviest of all 5-year-old boys in the entire world are. So that's when we just pick a ridiculously huge number. And I usually just do 5 9s. Remember, a lot of the videos you'll watch will actually do an even larger number. They'll do 1e to the 99, okay, which is 1 followed by 99 zeros. Okay, you can do that as well if you'd like to. Really, it's not going to make that big of a difference for these purposes. Then we'd have the mean of 43 and a standard deviation of 5. Okay, so we're doing normal CDF. So remember, we're in the distributions now because it's a normal distributions. So it's still second bars. Normal CDF is number 2. For number 8, the lower bound is 0. Upper bound is 36, mean is 43, standard deviation is 5. And remember, those of you who don't get that menu in your calculator, you will have to enter these commas. These are commas, not decimal points. And the comma button is here, right above the 7. Okay, we're going to hit enter, but we get a 0.081. So let's do the next one. And remember, we can just hit second enter to bring this back, and we can just arrow over and write over these numbers. Now I need a 50, and you see I have a 0. If I write a 50 there, that's going to erase the comma. So what I can do is I can use second delete. And you see how the way the number flashes changes? That means it's inserting. So you see above the delete it says INS. That stands for insert. So I can put my comma there. And now I have the values that I want. Except I've got to change this 36 to a 9. And I'm going to do that insert again, 999. And then just use the right arrow to get out of that. And you see how my cursor changed back to the black box. Hit enter, and we get 0.081. Crazy, right? What does that mean? We get the same exact value. If these two are the same probabilities in different ends of the graph, we know they have the same z-score. They have the same z-score. 36 is right about here. Okay, that's about negative 1.5, just guessing, somewhere around there. And if we look at 50, that's about positive 1.5. And we know that because they're both on the endpoints. Getting that same probability by itself doesn't necessarily mean it's the same z-score, but this is 36 and below, all numbers below, and this is 50 and all numbers above. So what we're doing is we're looking at a reflection. If we took this and we just flipped this whole thing on its side, then it would fit exactly over the one with the 50, assuming my drawing was correct. Oh, my drawings are pretty close. Okay, so let's talk about the percentile then. So we want to know what weight is the cutoff for the 16th percentile. So 16th percentile, does anyone remember? So if you're in the 85th percentile, that means you did as well or better than 85% of the other people. So if we're talking about the 16th percentile, then that means that better than 16% of the people. What that looks like in a normal curve, our mean is 43, and we want to know the cutoff for the 16th percentile. So we want to know if this probability is 0.16, what value goes here? And we did this in lesson 14. Remember when we were looking at the fish, we had said, well, what values of fish are the bottom 10%? What weights of fish represent the bottom 10% of weight? That was the 10th percentile. That's what we're finding here. We know the area is 0.16, and we want to find what X value goes with that. That's where we go up here. What we're looking for is we want to find what values of X starting from the left and coming in. Okay, and so we want to add these up, add that, until we get to, since they're percentages, we want to get to 16. We have 0.15 plus 2.35 plus 13.5. Is that 16? That seems like that might be 16%, doesn't it? That's the 0.16. If we add all of those up, we get 16%. Okay, so 38 pounds and below. Okay, so that looks familiar. All the times we've done that, we've been given these exact areas from lesson 14. Okay, remember we were doing that fish curve here? We were finding the largest 7% of fish. Largest 7% of fish isn't the 7th percentile, it's 100 minus 7%, so it's the 93rd percentile. And then the smallest 40% of fish, this is the 40th percentile. Okay, because the percentile always goes from 0 up to a point. So that's what we're doing with this example. Okay, we found this area here. This is the 16th percentile. And looking at our graph, it's this here. It's the 16th percentile. We want to be able to find what values make up percentiles for the areas in between here. We want to find values where the probability isn't on one of these standard deviation integers. That's where we use the calculator. I'm going to show you how to use the calculator finding this value here. We found this value just using our normal curve, but we can use it on the calculator using a function inverse norm. And it's called inverse because we're going the opposite direction of what we normally do. And all of these, I'm given the X values on my normal curve, and it spits out a probability. Now I know the probability, and I want to find the X value, so I'm doing the inverse operation. Inverse operations, addition, subtraction, multiplication, division, squaring, square rooting. Those are all inverse operations. We have an inverse operation with our normal curve as well. And so how that works is we're going to put in the percentile / area. I'm stressing the fact that it's a percentile because the calculator can only do this for area from the left to a point. It can't find top 10%. It can only find 90th percentile. So it can only find this bottom area here. And these instructions are actually here. Okay, so we're going to put in the probability as a percentile, and then we're going to put in the mean and the standard deviation. Similar idea of what we're doing here for the normal CDF, where we've got the mean and the standard deviation, but instead of putting the X values, we're going to put the percentile or the area instead. We're going to do inverse norm, and the percentile is 0.16, the mean is 43, and the standard deviation is 5. Second bar. Okay, and you see the third one down right below normal CDF is inverse norm. So press enter. The area we want to find is that 0.16, the mean is 43, the standard deviation is 5. Now, here's the thing. Do you have a calculator that gives you this? If you have a calculator that gives you this menu, you're in luck. The tail is referring to basically what we did in questions 8 and 9. We found the tails, the area of the tails, or it can find the center bits, which is like what we did in question 7. Most calculators don't have this. This is a new addition for the CE versions. So we want to find the left one. If you don't have this menu option, it only knows how to find the left one. So we're going to put paste. If you don't have this option, what you're going to have on your screen, it's going to look like that. You're going to have to enter this in manually and do 0.16, comma, 43, comma, 5, just like you had to if you would have had to enter in the normal CDF manually. And I'm going to press enter, and I get 38. If you put in right, you would find that reflection area, basically like we did in 8 and 9. You would find the top 16% instead of the bottom 16%. Okay, I'm going to have you work on example 3. If you finish 3, you can go on to 4. Okay, notice it does tell you that the pregnancies are normally distributed in example 3, and that's how you know to use normal CDF. On the tests and quizzes, if it's not normal, it will tell you it's a binomial distribution, and that's when you would use binom. And remember, the binomial distributions, we are using both PDF and CDF. But for the normal distributions, we're only using CDF. We're not using that PDF. Okay, but the same is true for PDF versus CDF. The PDF tells you the probability of exactly one event happening, but we're doing CDF. We're always doing a range of events, a cumulative events. So you notice that here you're asked for what percentage of pregnancies will last over 280 days, or you could say what's the probability that a pregnancy lasts over 200 days. In both of these, so you're either asked for a probability or a percentage, and that's how you know that you're going to use normal CDF to find a probability. And I realize that it's asked for what percentages, but I didn't give you a percentage, did I? So this is 18.7%. In part B, I'm asked, this should be 26%. And then here, I'm asked, what is the top 5% of pregnancy length? So I'm given the percentage, and I'm asked to find the X value that goes with this. And remember, top 5%, I have to have a percentile in here, so you have to translate that to a 0.95. Finding the X value that goes here to demark this probability, but for my calculator, I have to refer to this section here. And that's why thinking about it as a percentile is a lot easier, I think. Okay, and then in example 4, where you see how I made my normal curve? I suggest you do this with everything just to get into its good practice. And these are X values. Again, I'm asked for what percentage, and again, I did not put the percentage. I didn't read my own problem, folks. Sorry about that. And this one is 20.2%. And then here I'm trying to find the lowest 1%. So that is the first percentile, 564 pounds. And that matches, right? Because if we go over here to our curve, okay, so this is about 560 pounds. And look at that, matches the graph I drew. Now let's talk about choosing between normal CDF and inverse norm. Because here's the thing, is that on the tests and the quizzes, I'm not going to tell you which one to use. You're going to have to pick out which one to use. So you're going to have to use those cues I'd pointed out. Number 20, we have the weight of a newborn elephant is normally distributed with mean 225 pounds and a standard deviation of 45 pounds. I don't know if you've noticed, but I always write the mean and standard deviation up here just to pull them out so they're easy to find, because you're going to be using them in every single one of these problems. Just another good habit to get into. To find the top 10% of newborn elephant weights, what are we going to use? Normal CDF or inverse norm? Think about that for a moment. So in each of these, I've like 4 or 5 different scenarios. I am going to ask you which one we're going to use, and then I'm going to have you write down what you would put in your calculator and find the thing that we're talking about. So is it normal CDF or is it inverse norm to find the top 10%?
Inverse norm.
Inverse norm, yay, excellent. Because I'm told the percentage. And remember, this is the percentile, then the mean, then the standard deviation. What is the percentile then? Is it the 0.10 I'm going to put in here? No, it's the 0.90. And the mean is 225. Standard deviation is 45. Bust out your calculator and hopefully you should get 282.7 pounds. So what we're finding is this right here, where this is 10%. So part C, find the probability of a newborn weighs more than 300 pounds. Normal CDF or inverse norm?
Normal CDF.
Yay! How did you choose that one? Was there a word or a phrase in particular?
More than 300 pounds.
Right, that's one of them for sure, because here you're told an X value. Here's my 300, and what I want to find is there. And you could also notice that it says find the probability would be another cue. What you can remember is here I'm given a percentage. That's what tells you it's inverse norm. But if I'm asked to find the probability or find the percentage, that's when we're doing normal CDF. So with normal CDF, we're going to do min, max, mean, and standard deviation. So our min here is 300. Now our max, again, we're doing more than, so we don't know what that max is, so we have to pick a super huge number. And I'm already at 300, so I'm gonna add 6 nines just for good measure. Or remember, you can also do 1e to the 99, and then the mean is again 225 and 45. Put that in your calculator and you get, let's see, what did I get? I got 0.048. Notice here, my graphs are not to scale, okay? Because this shows more area than this, but this is 10% and this is only 5%. So my graph is very inaccurate. Here's the area we found for D. And for part B here, part B, I mean. Okay, so E, we're asked to find the probability an elephant weighs between 250 and 275 pounds. Okay, so again, we could go back up here to this graph. This is why I like using this graph. It really helps visualize what's happening here. Okay, so we're asked to find the probability an elephant weighs between 250 and 275 pounds. You see, I'm given the weight. That's this area here. All right, so I'm asked to find the probability. So that is going to be normal CDF. Find the probability means that CDF is happening. 250 is going to be the min. 275 is our max. So it's normal CDF 250, comma, 275, comma, 225. Comma 45. Put that in your calculator and you should get 0.156. So let's try G. Circle which one you think it is. Write down what you would put in your calculator as well. In part G, we're asked to find the bottom 25%. We're given a percentage and we want to find the weight. Okay, so that means we're looking at inverse norm. The area is 25%, 0.25, because it's bottom 25%. This area is 0.25, and I want to know what value is associated with that. So we're going to use inverse norm. The bottom 25% is the 25th percentile, so we can put in a 0.25. Mean is 225. Standard deviation is 45. Put that in your calculator and you should get 194.6 pounds. And does that make sense with my graph? If I look here, right, this is half. And I want to find 25, so right about there seems about right. If you look at the graph, that's, maybe, about 190. That makes sense. It wants to know what are the bottom weights. So I can't just put this. This is just one weight. I need a range of weights. So it's actually 194.6 pounds and below. You'll notice on the homework, I'm asking you that question and then I'm writing it in probability notation. So hopefully you're getting familiar and used to it. So in this previous one in part D, this would be the probability that X is greater than or equal to 300. That would be the probability notation. In H, when we're finding the X value, there is no probability notation because we're not finding a probability. So we would only use the probability notation if we're using normal CDF. These go together. Practice on number 21. I would suggest you not looking at my answers. Just try your hand at all of them, just guessing which one it is, and then go ahead and look at the answers, okay? Those cues of, are you told the percentage or are you asked to find the probability? Okay, and remember, I am here for the next 20 minutes after class if you want to stick around. I'm always here till 1 o'clock, and I'm here before class too, remember, if you want to ever pop in early and ask me some questions. All right, with that, have a great afternoon.